if you talk about communities, communities are same as tagging that you used in EICRP as well as OSPF. In BGP, communities are same as what? Tagging in OSPF and EICRP. Like in OSPF, you added some tags, tag value during redistribution. In EICRP as well, you added some tag values during redistribution, and then finally you used those tag values just to match your prefixes and all. What was the uses of tagging in OSPF and in EICRP and in RIP? Just to match your prefixes. Like in route map, we could say match tag. Match tag. So basically with using those tag values, we were matching all those prefixes, right? Have you understood it? Fine. In same manner, in BGP also we are having communities. Communities are optional transitive attributes. Communities are optional transitive attribute. What does it mean? It means that it is an optional attribute, means that if you enables your BGP to carry this attribute, then only it will carry this attribute. Or if you enable this attribute, if you enable BGP to carry this to use this attribute, to carry this attribute, then only BGP will start to use this attribute and also will start to carry this attribute within its updates. That is why we are calling it as optional. Now it is transitive. Meaning by transitive is that in case if any device, if any BGP router do not understand, do not support this attribute, then also that router can accept these prefixes, and after receiving those prefixes, it can remove those communities. I mean, it can remove that attribute and also can pass those prefixes towards another neighbor. That is why we are calling it as a transitive attribute. Have you understood it now? So basically this community is a optional transitive attribute. Optional is because here it is not, I mean, it's not well-known attribute, because by default BGP will never use these communities without enabling it. So if you wanna use communities here in BGP, then first of all you will require to enable it over here, right? So now next thing is about communities, like community means we are talking about tag values. It is a 32 bits long. It can be 32 bits long value. Means that range of communities would be from 1 to 4.2 billions in decimals, right? And one more thing, in communities, we have two types of communities: standard, and I think it is extended or expanded, something like that. I think it is extended. Let me show you. Extended, right? So we are having two types of communities here in BGP: standard and community. Sorry, standard and extended. In most of the cases here in CCRNS version 5, you will be using, or you will be configuring only and only standard community. I'm not saying that in BGP there is no use of extended, I mean this extended community. Definitely I will also use this extended community, but this extended community will be used by BGP for itself. You will not configure this extended community for BGP. You will not set it by yourself. However, it is possible to set extended community as well in BGP, but in CCIE RNS version 5, it is not in our curriculum to set extended community into your BGP manually. but it does not mean that it will not be using this extended community. No, it will be using this extended community in BGP. And in which cases it will use extended community, I'll be discussing it later on, like during MPLS I will teach you that okay, this is the extended community used by BGP. And also here I will teach you unequal cost load balancing in BGP. In that case also, I mean over there also I will teach you that okay, in this way see BGP is using extended community. So I'm not saying that here BGP will not use extended community, it will use it, but BGP will configure this extended community by itself. Communities, that why will we use these communities, where can we implement or can we utilize these community values or these tag values. So see, BGP communities are a means of tagging routes to ensure consistent filtering or route selection policy. So the only and only uses of community will be just to match your prefixes. And after matching your prefixes, now you can take any decision. Like if you wanna filter routes, then you can filter. If you wanna perform some path manipulation for them, then you can also perform path manipulation. See, till now, if you are remembered that in route map, just to match your prefixes, I was using either standard ACL or prefix list. Are you getting my point or not? But if you are using standard ACL or prefix list, see in BGP table you can have like 100,000 routes, 100,000 prefixes or more than that, like 200,000 prefixes. Will it be really possible for you guys to create prefix list or like ACLs to match your prefixes? Yeah, it is possible, but it will increase so much overhead over administrator. So what do we do usually in production networks at the end of service providers, that we allocate community values to all prefixes. Like for an example, Airtel is using this subnet. So Airtel, whenever Airtel will advertise its own prefixes, it will advertise all those prefixes with its own community. Idea, whenever Idea will advertise its own prefixes into BGP table, it will advertise those prefixes with its own community. Now, let's say that I want to match all those prefixes which are coming from Airtel. I don't need to create any standard ACL or prefixes. I will simply match my prefixes with the help of community. Have you understood it or not? So this is the uses of community, and that is why they have mentioned here to ensure consistent filtering or route selection policy. I mean, you can also manipulate your path selection of BGP after matching your prefixes, right? I mean, the uses of communities will be same as like standard ACL or prefix list. But it will be easier to match your prefixes with using communities. Then any BGP router can tag routes in incoming or outgoing updates or when doing redistribution. So in BGP, if you are doing redistribution, then you can set community. I mean, you can perform tagging. If you are giving an update to your any neighbor, whether it is IBGP peer or EBGP peer, then also you can perform, you can set tag in both direction, in outbound or for incoming updates as well. By default, communities are stripped in outgoing BGP updates. What does it mean? That by default, communities will never be part of BGP update packet. That's what I said, that it is an optional attribute. By default, BGP will never carry this attribute along with its BGP update. Are you getting my point or not? So that is why by default communities will be stripped from outgoing BGP updates. Now next is what? BGP communities are attributes that are used to group and filter routes. Communities are designed to give the network operator the ability to apply policies to large number of routes by using match and set clauses in the configuration of route maps. Community lists are used in this process to identify and filter routes by their common attributes. A community is an attribute that is used to tag BGP routes. A router can apply it to any BGP route by using a route map. Other routers can then perform any action based on tag that is attached to the route. Simple. As I said, 32-bit long number, 4.2 billions, right? And it is starting from 0. But I think you can allocate it from 1 only. I mean, I will show you practically that you can allocate it from 1. We will see that each network in BGP routing table can be tagged with a set of, I mean, it is not like you can set only one tag value, like in OSPF or in ICRP it was possible to add only one tag value, but in BGP, same as AS path list, you are having community list. Same as AS path list, you are having community list, and in community list you can have multiple communities. Understood? Then there are some standards defined. Several filtering oriented communities are also available, and these are, by looking at these communities looks like named communities, like no advertise. I mean, this is also kind of tag, and this is actually value. This is a specific value, but they have converted those values into names. I mean, these are predefined communities actually, like not advertise, no export, local AS, internet. Try to understand. Apart from these decimal communities, you can also allocate your named communities as well, but under named communities we are having only these 4 options: either no advertise, no export, local AS, or internet. You can use any one of them. Right? Fine. Now the question is, what is the uses of not advertise? See, let's say that I am an ISP. I'm an ISP. If I am an ISP and I'm having neighborship with my customer, this is ISP and this is, let's say, customer router. Fine. And now ISP wants this customer router must not be able to advertise my prefixes to any other BGP router, whether it is iBGP neighbor or eBGP neighbor. For customer, let's say there is only one router R1 connected to it, and then it is also having some other routers as well, R2. ISP have given some prefixes to this router R1. This is R1, customer edge router. Now I don't want let my customer edge router to advertise these prefixes towards any other neighbor, whether it is iBGP neighbor or eBGP neighbor. Finally, I don't want to let my neighbor to advertise my prefixes towards any other neighbor. So I can advertise, I mean ISP can advertise those prefixes with community, not advertise. So if ISP is advertising prefixes towards this customer with community, not advertise, in that case this customer R1, this customer router R1 can accept these prefixes, can install these prefixes into its routing table, but will not be able to advertise them towards any other neighbor, whether it is iBGP neighbor or eBGP neighbor. Understood or not? Tell me. So this is the uses of not advertise. That is why here if you see its definition, what does it mean? Do not advertise route to any peer. So if any router, if any BGP router receives any prefix with community, no advertise, it will never advertise those prefixes towards any other peer. Next is what? No export. Now let's say that ISP wants that its neighbor should be able to advertise prefixes towards its IBGP neighbor but not to EBGP neighbor. I got your point? Now ISP wants that its customer router should be able to advertise its prefixes towards IBGP neighbor but not to EBGP neighbor. In that case, ISP can advertise those prefixes with the community no export. Understood? So if any BGP router receives any prefix with community no export, in that case it can advertise those prefixes towards IBGP neighbor but cannot advertise them towards EBGP neighbor. So what does it mean? See, do not advertise route to real EBGP neighbor, but see, still it can advertise these prefixes towards confed EBGP neighbor. Do you remember? Okay. Wait. We missed something. Route reflectors and confederation. And before community, we have to do that. It's not possible, or it will not be good for us to go for communities before going for route reflectors. And but I hope that you people have understood. I mean that what is the use of this community. The only thing which is left now is implementation, right? So I'll be doing implementation after covering route reflectors and confederation only. First of all, that is mandatory, route reflectors and confederation, right? So we have to stop this topic now. At least theory is done of communities, right? Theory is completed now. The only thing which is left is practicals, and I will cover practicals of communities after covering route reflectors and confederation. So today let's go for first of all route reflectors. See, route reflector, you know very well that why do we use route reflectors in the network? Just to break the IBGP rule. By default, what happens that if your BGP router is receiving any information from its IBGP neighbor, then it does not advertise that information towards any other IBGP neighbor. Understood? This is the default rule of IBGP. Now if you want to break that rule, then you have to use route reflectors. And in BGP, if you talk about the route reflectors, there are three things. First, RR. Second, and third one is what? Non-client. Fine. And you know very well that what is the functionality of these things and how can we configure them, right? You know very well that which router will be known as route reflector and which will be known as client and which will be known as non-client. Now remember, route reflector I mean to say server, you can also call it server. So it can reflect routes in between client, non-client, between client, but it cannot reflect routes between two non-clients. I hope you people remember these things, these rules, because I have already discussed all these things with you, right? Now the problem with me is like this is R1, this is R2, and this is, let's say, R3. If there is a prefix 10.1.1.0/24, it will give it to R2, but R2 will not give it to R3. Let's say all of them are IBGP neighbors, right? So now I will make this R2 as route reflector Once I will configure this R2 as route reflector, it will start to advertise this prefix in the direction of R3. R3 will receive this prefix information from R2, but it will not advertise it towards R1 now. But again, I can configure this R3 as a, then it can send this information back to, is not it? And now there can be a routing loop. If R1 accepts this information coming from R3, then of course there can be a routing loop. So how can we prevent our network from routing loops in case if you are using route reflectors over here? Are you getting a point or not? Tell me. BGP to prevent itself from routing loops even after using route reflectors as well. So remember that if you are using route reflectors in your BGP, then there will be two new attributes come in. After using route reflectors in BGP, there will be two new attributes will come in. First, originator ID, and second, cluster list. These two new attributes will take place into BGP just after configuration, just after configuring route reflectors. Originator ID and cluster list. Fine. Now what is the meaning by originator ID? See, this originator ID will be router ID of that router, of that BGP router from which BGP, or you can say from which route reflector received prefixes. Originator ID will be router ID of that router from where route reflector received prefixes. And cluster list will be having cluster ID, cluster IDs. Now the question is that what is the cluster ID? Cluster ID is router ID of route reflector. Cluster ID is a router ID of route reflector by default, but you can modify it. See, cluster ID can be modified, but originator ID cannot be modified. Originator ID will always be router ID of the router, and cluster ID will be by default router ID of route reflector, but you can also modify your cluster ID. I mean, you can modify it. It can be different. It can be different from router ID. How does it work now? Just try to understand. Let's say again you are having the same topology R1, R2, then R3, and then once again R1. Let's say its router ID is 1.1.1. On R2 its router ID is 2.2.2. On R3 its router ID is 3.3.3. In the lane of R1, let's say we are having 10.1.1.0/24. Now it will advertise it in the direction of R2, but before configuring route reflectors, R2 will not be able to transmit to advertise them towards R3. Now let's say that you configured it as a route reflector, and this is what? Client, and this is also what? Client. Fine. Now because R2, this time R2 will start to advertise this prefix in the direction of R3, but remember that whenever a route reflector will advertise prefixes towards any other IBGP neighbor, before advertising them it will add two new attributes now into your BGP updates for all prefixes, right, which are coming from R1, but this time you are receiving only one prefix. So before advertising this prefix towards R3 in the direction of R3, it will add two new attributes now. One, originator ID, and now originator ID will be, see, on R2 originator ID, because R2 received it from R1, so originator ID will be, now it will also add one another attribute, which is cluster list. You understand? So what is the meaning by cluster list now? It will be containing cluster IDs. It will be containing cluster ID, and cluster ID is what? Router ID of route reflector itself. So what is the router ID of route reflector this time? And after adding these two new attributes into it, now it will advertise this prefix in the direction of R3. Now R3 will receive it from R2, which is IBGP neighbor, but R3 will not advertise it in the direction of R1. Now if you want that R2 should advertise, sorry, R3 should advertise these prefixes towards its other IBGP neighbors, then you have to define this R3 as a, it means you will define this R2 as a
client,
and this R1 as a client, and now R3 will start to advertise this prefix back towards R1, and now prefix was 10.1.1.0/24. so before advertising it in the direction of R1, again it will be, I mean, if it is already having originator ID, then it will keep that originator ID. And if there is no originator ID, then definitely this time in originator ID R3 will put the router ID of R2, but this time this prefix was already having originator ID. So if prefix was already having originator ID, then it will not modify that. Remember, originator ID will never be modified. Once it has been allocated, then it will always keep that originator ID. So it will remain as
1.1.
now it will also be having cluster list, and it does not mean that it will replace previous cluster ID, no, because this is cluster list, same as AS path list. So previously this prefix across traverse one route reflector, which was 2222, so it was already having 2222, but now because it is also traversing this R3, so apart from 222 it will also be having 3.3.3, and then it will advertise it back to R1. Now when a router receives, try to remember, if router receives a prefix from its IBGP neighbor along with originator ID and cluster list, first of all it will check its cluster, I mean it will check actually both of them. It will check cluster list as well as it will check originator ID. If its own router ID is same as originator ID received inside prefix, if a router's router ID is same as the originator ID received in prefixes, then it will simply discard all those prefixes. It will simply discard all those prefixes. In same manner, if a router receives any prefix and in that if cluster list is having its own cluster ID, then also it will discard it. It means in case this prefix goes back to R2, then R2 will not accept it, R2 will discard it, because R2 will find its own router ID, its own cluster ID inside cluster list. It's same as like AS path list, like if any router receives a prefix with its own AS, then it will simply discard it. In same manner here also, if a router receives any prefix with its own cluster ID, it will never accept that prefix, right? So originator ID and cluster IDs, these two new components will take place to prevent your BGP from routing loops. Fine, great. I hope you people have understood that how will it work actually. So remember, once it has allocated originator ID, it will always keep that originator ID, whereas cluster IDs will always keep on to prepend into cluster list. So whenever a prefix will across one route reflector, it will always add its own cluster ID into existing cluster list, but originator ID will always remain same. In same manner, see, if this is R1, this is R2, this is R3, and this is R4. Try to understand now. This is eBGP here. Here you are having IBGP. Here also you are having IBGP. Now, of course, R1 will give it to R2. R2 will also advertise it towards R3, but R3 will not advertise it towards R4. So, prefix is coming from R1, 10.1.1.0/24. You see. So whenever R3 will be configured as route reflector, it will be client, it will be client. So before advertising this prefix towards R4, it will add again two things. One, originator ID, tell me, and second, cluster list. So in originator ID, however, this prefix is originated from R1. So what will be originator ID here on R3? I mean, of course, R3 is advertising this prefix in the direction of R4. So what will be your originator ID? It will be router ID of R2. You know why? Because R3 is receiving these prefixes coming from only R2. Doesn't know anything about R1. So remember, originator ID will always be router ID of that router from where route reflector received prefixes. Fine. And once originator ID has been allocated to your prefixes, then it will never get changed, even after closing multiple route reflectors itself.
So if we have neighborship between R1 and R3, then originator ID will be R1.
But in that case, why will you configure? eBGP cannot be your client.
Okay.
Remember, you cannot define your eBGP neighbor as a client. Route reflectors are made for IBGP peers only. Fine, guys. So here, when R3 will advertise these prefixes towards R4, originator ID will be router ID of R2, and inside cluster list, it will be having its own cluster ID. I mean, router ID of R3.
अगर ये अपडेट R4 अभी कोई eBGP नेबर को देगा तो ये एट्रीब्यूट उसमें कैरी करेगा अपडेट ये वाले?
Never. Remember, this originator ID and cluster list cannot across your own AS. It cannot across. But these attributes comes under optional attributes, right? Because if you are not configured route reflectors, it means these attributes will not be in use. But if you have configured it, then definitely these attributes will be in use. That is why these two attributes comes under optional attributes. Fine, guys. Great. Let's say this is R1 and this is R2, this is R3, and this is what? And your BGP pairing is something like this. So you have to define this R1 as a, and it will be, in case if R1 goes down, will it be possible for R2, R3 and R4 to communicate with each other? So this is called single, I mean, this is like without redundant route reflector, right? Hey guys, try to understand. This is a single cluster without redundant route reflector. To solve this problem, now we can have another router like R5. Even you can also form IBGP pairing between R1 and R5. Now you can define R1 and R5, both of them as route reflector. For R5 also configure R2 as client, R3 as client, R4 as a client. Now in case if one route reflector goes down, another will be in use. But remember, on both routers configure common cluster IDs. Configure, then it will be known as single cluster. In a single, see what is the meaning by single cluster? Means that where you will be having only one cluster ID. So if you do not configure common cluster IDs onto R1 and R5, if R1 is giving any information to R5, R5 will accept it. And if R5 is giving any information to R1, then also it will accept it. However, if R2 is giving anything to R1, R1 will give it to R5, R5 will give it back to R2, but R2 will discard it because R2 will get its own originator ID onto received prefix. There will not be any loop even if you do not configure common cluster IDs onto both route reflectors. But it is always recommended that if you are talking about a single cluster with redundant route reflector, then on both route reflectors configure common cluster ID. So what does it mean? If you are having common cluster IDs, let's say here 1 1 1 1 and here also 1 1 1 1 1, if any prefix is given from R2 to R1, let's say route reflector. Now for this R1, this R5 is what? Non-client, because R1 and R5 are also having IBGP neighborship, but for R1, R5 is what? Non-client. But after receiving any information from one of the client, it can advertise it very easily towards what? Non-client. R5 will accept it if cluster ID is not same as R1. Are you getting my point or not? However, of course, R5 should not receive it from R1 because R5 is already receiving them from R2, because R5 is already having neighborship, IBCP neighborship with R2. So there is no need to receive prefixes from R1 onto R5 and from R5 onto R1. That is why, and here, because we are talking about a single cluster, so in a single cluster, if you are having multiple route reflectors, make sure that all of them are having same cluster ID, then only we can call that, okay, all of them are in a single cluster. Try to understand the definition. We are saying that in a single cluster, we are calling them as a single cluster, right? So in a single cluster, all route reflectors must have common cluster ID. Common cluster ID. Fine. So configure common cluster IDs on R1 and R5, right? So it will be known as single cluster. But remember, there can be a problem if you are configuring common cluster IDs onto multiple route reflectors. In case if you are having multiple clusters, like in this way. This time both route reflectors were having peering, IBC peering with same routers, with common routers, right? Like R1 and R5 were having neighborship with R2, R3 and R4. But in case if you are having this kind of network like R1, R2, R3, R4, R5 and what? R6, in this way. Now, of course, you will require to configure this R1 as a route reflector, client, and then also you will require to configure this R4 as a route reflector. It will be client and client. For R1, R4 will be non-client. For R4, R1 will be non-client. Hello.
Yeah.
So this time, see, this is one cluster, and this is another cluster. This is, and if you are having this kind of network now, make sure both route reflectors are having different cluster IDs, because if they are having now common cluster IDs, see, now there are two separate clusters, because R1 is having neighborship with different routers and R4 is having neighborship with different routers. So in this manner, it is mandatory that R1 and R4, both of them must have different cluster IDs. Because if they are having same cluster ID, now what will happen that if R2 is giving an information to R1, R1 will give it to R4, R4 will discard it, because it will find its own cluster ID available inside cluster list. So if you are having multiple clusters, then make sure that all route reflectors are having different cluster IDs. If you are having a single cluster, then make sure that all route reflectors are having same cluster ID. So I hope that you people have understood the uses of originator ID and cluster IDs. So these two new attributes will take place or will be responsible to prevent your BGP from routing loops after breaking IBGP rule. This is all about route reflectors, or this is advanced route reflection. Fine guys, so in this way you can understand this route reflector. So I'll be discussing it, I'll be doing all these things, I'll perform all these practicals, but before performing the practicals of route reflectors, let's discuss something related to confederation as well. See, the problem is, like, if you are using only and only route reflectors, then it is not much scalable. It is not much scalable as well as reliable too. This route reflector in a enterprise network, in a large network, that's the problem with route reflectors. Like, you will require to configure so many route reflectors. Are you getting my point or not? You will require to configure a lot of route reflectors. So to reduce the requirement of route reflectors, see, I'm not saying that I will not use route reflectors. Actually, in industries we use route reflectors along with confederation. We will be using the combination of both of them, confederation as well as route reflectors. So basically confederation came just to reduce total number of route reflectors in your AS. Like in a single AS, if you are having like a huge number of routers, like 200 or more than 200 or 100 routers, like 100 routers, then of course you will require to configure so many route reflectors. But confederation can reduce the requirement of number of route reflectors. Understood? Actually, do you remember private VLANs?
Yes, sir.
Private VLANs.
Yeah.
In private VLANs, what do we use? What do we do? Like we were having one private VLAN, and primary VLAN, and under primary VLANs we created some secondary VLANs. But whenever traffic was going up from the, whenever traffic was going through the trunk port, it was always going with primary VLAN.
Primary VLAN.
It was having the type of primary VLAN only. In same manner, in confederation also, there will be one primary AS which will be your main AS, and there will be some sub ASs under primary AS, under main AS. Right? So let's say this is R1, this is R2, this is R3. Wait. Fine. All of them, let's say, are in same AS. Here on R1, let's say it's using AS. I mean, now I have to configure some sub ASA. So you can do one thing. You can configure here AS10. AS10. AS20, and here also AS20. So here it will be intra-confed neighbor. I mean IBGP. Here it will be EBGP, and here it will be IBGP. But see, this is not real EBGP. This is confed EBGP. This it will be known as confed EBGP. So this confed EBGP have some features of real IBGP neighbor and some features from real EBGP neighbors. It is not completely it does not have completely features of real IBGP or complete features of real EBGP. It has the combination of both of them. I mean, this confed EBGP neighbor or this peering have some features of IBGP and have some features of real EBGP. Like, you can advertise your prefixes to your confed EBGP without any problem. This feature was taken from real EBGP, but it will carry local preference for confed EBGP. This feature taken from IBGP. Next hop will not get changed. This feature also came from real IBGP. Hey, if you are giving an update to your real EBGP, then it is mandatory to update its next hop address. But if you are giving an update to your confed EBGP, then next hop will not get changed. That is why I said that this confed EBGP will be having some properties of real IBGP neighbor and some properties of real EBGP neighbor. So is it required over there now to configure route reflector? Of course not, because R1 can easily advertise any prefix information to R2. Then R2 is having EBGP neighborship with R3, so it can pass it towards R3, and then because R3 is received from EBGP, can give it to IBGP towards R4. So there will not be any requirement of configuring route reflectors. Right? Remember that within primary AS, these sub ASs will always be prepended in outgoing updates. Like whenever prefix will across sub AS10, its information will be appended, or you can say will be added into your outgoing BGP updates. But whenever prefixes will go out from their primary AS, I mean real EBGP neighbor, let's say this is ISP, so they will go with AS65500 only. There will not be any information of sub ASs whenever it will transmit an update towards real EBGP neighbor.
There will not be. I'm writing.
What?
You said there will not be.
What I said, that whenever updates will go towards real EBGP neighbor, it will never give any information about sub ASs to its real EBGP neighbor. So it is same as private VLANs. I hope that you people have understood the uses of confederation. And if you are using confederation, then again there will be some new attributes into BGP, like confed type, whether it is confed external or confed internal, confed type and confed AS list. Confed type and confed AS list. These two new attributes should be added into your BGP. But within an AS, whenever prefixes will go out from the main AS, whenever updates will go towards real EBGP neighbor, then these two attributes will be removed from outgoing updates. So there will be two new attributes added. One, confed type. It will be either internal or external. If your neighbor is confed IBGP neighbor, then it will be confed internal. And if your neighbor is confed EBGP neighbor, in different sub AS, Like for R1, R2 is what? Confed IBGP. For R2, R3 is what? Confed EBGP. So confed type and confed AS list. These two new attributes will be added into your BGP now. But remember, these sub ASs will never participate in your best path selection process. Your best path selection process of BGP will remain same as previously. These sub ASs will never participate in your best path selection of BGP. Understood? So this is that how confederation works. Along with confederation, you can also use route reflectors, like in this way. For an example, this is ISP 1 and this is what? ISP 2. It is connected with R1. You understand? And let's say this is R1. Then it is connected with R2, with R3, as well as with R4. This R1. And then further this R4 is connected with R5, R6, R7 and R8. And R6 is further connected with ISP2. So what can we do? I mean, this is your main AS. I mean, this is your entire diagram. So here, let's say that you are using AS65500, but you decided that okay, let's do one thing here. These 4 routers will be in sub AS. Tell me 10, and these 4 routers will be in sub AS 20. So updates can go from R4 to R5 very easily, from R5 to R4 very easily. But thing is, R1 will still be required to configure route reflector, because all these 4 routers are in same sub AS. If you do not configure this R1 as a route reflector, then how will it be possible to exchange prefixes in between R2, R3 and R4? So in same manner, R6 will also require to configure route reflector, and all others like R5 will be client, R7 will be client, R8 will be client, R4 will be client, here client, right? So see, even with using confederation as well, you are required to configure route reflector. So basically in live networks, we will be implementing route reflectors and confederation combinedly in this manner. Have you understood it or not? Because if you do not configure here route reflector and you have configured only confederation and you used only 2 sub ASs over there, so in that case it will not work fine. It will never work fine actually. So I hope that you people have understood that. What are the differences in between confederation and route reflector? So in confederation, I mean, of course, the uses of both of them is same, is common, just to break your IBGP rule, but the functionality is different from each other. Like in route reflectors, you are using this originator ID and cluster list, whereas in confederation you will be using some sub ASs. So there will be concept of confed IBGP or confed EBGP, is not it? So that's the only difference in between route reflectors and confederation. So in confederation you will be using sub ASs, whereas in route reflectors you are not required to use any sub AS. So I will implement all these things now. First of all, I will implement route reflector and then I'll go for confederation. So here first of all, I'll teach you that how to configure redundant route reflector in a single cluster. How to configure redundant route reflector in a single cluster. So I'm going to design this network in this way. Like I'm having R5, I'm having R1, R2. I don't have the console of R3, so that I'll take R4. So that R1 will be have R1, R2 and R4 will be having IBGP neighborship with R5. R1 will be having its lane, R2 will be having its lane, R4 will also be having its lane. Then R5 will also be having its own lane. And then R1, I will also form IBGP peering in between R1, R2, R4 and in between R1, R6, R2, R6, R4, R6. So that we can have redundant route reflectors here. And then I will also form neighborship in between R5 and R6 as well. But for R5, I will not configure R6 as a client. For R6, I will not configure R5 as a client. So I will configure this R5 as route reflector. R1 will be client, R2 will be client, R4 will be client, R6. I'll configure R6 as a route reflector. Then R1 will be client, R2 will be client, and R4 will be client. Fine. Let's design this network now. And I'll break neighborship with ABCP neighbors and all, right? So this is your physical diagram, but you know IGP is running. So I can configure BGP peering in that manner, right? Hello, OSPF is already running over there.
Yes.
So all of them are having reachability with each other. So there will not be any problem related to reachability. No router BGP 65500. First of all, let me remove it from all of them. From R2 also. Fine. Now, I will start doing configuration from R5, and I will also teach you the uses of peer group as well along with this configuration. I will also tell you that how to configure peer group. So basically on R5 I will be using peer group command now, because I'm having, how many neighbors are there? 3. So let's say that all of them I have to configure like update source loopback, route reflector client for all 3 neighbors, and next hop self as well, because R5 is also having neighborship with EBCP neighbor as well. So whenever it will receive any prefix coming from EBCP neighbor and if it advertise them towards IBCP neighbor, it will not modify their next hop address. So you will also require to configure next hop self command as well, right? So for each neighbor there will be 4 commands. Total number of neighbors are 3, total number of commands will be 12. To reduce this total number of commands, we can use here peer group. Hello, first remote AS, second update source, third route reflector client, fourth is what? Next hop self. So move on R5 now. Fine. And on R5 now I will use this peer group, this concept of peer group, right? So I'll say router BGP 65500, neighbor is CCIE. Remote AS is what? Sorry, first of all I have to define that it is my peer group. So peer group, and then say neighbor CCIE remote AS is what? 65500. The neighbor CCIE update source, the neighbor CCIE route reflector, the neighbor CCIE next hop, and then say neighbor 150.1.1.1. Are you getting my point? Is a member of peer group. So all those commands that you configured onto that peer group, within that peer group, will be applied for this neighbor automatically. And then say neighbor, and then 4.1, because I'm having neighborship with 1, 2 and 4. In same manner, you can copy and paste your configuration from R5 to R6 as well, because commands will remain on R6 as well, because R6 is also having neighborship with same routers. Fine. And then let's move on R1, and let's configure this R1 65500 neighbor 150.1.5.1, and it is not mandatory to use peer group on both sides. Here I'm not gonna to use peer group right at the end of R1. So neighbor, say remote AS is what? The neighbor 150.1.5.1, update source is loopback 0, then that's fine. Then neighbor 150.1.6.1, remote AS is 65500, and then update source is what? Loopback 0. Check its BGP tables, BGP neighborship, show IP BGP summary. So it has formed a neighborship with R5, and neighborship will also come up with 6 as well. It have came up now, see. And now I also told you that I'll be using one loopback here on R1. Like I can create one loopback 1 and 10.1.1, and I will advertise it into BGP now. Router BGP 65500, say network 10.1.0, and mask is what? /24. So I have advertised it into the BGP now. Then move on R2. Router BGP 65500 neighbor 150.1.5.1, remote AS is what? Create one loopback on R2. I will be using the subnet 20s, and then show IP BGP summary, check it out with both of them, right? Then after, move on 40, router BGP 65500 neighbor 150.1.5.1, remote AS in same manner, and then say check it out. With R5 neighborship have came up, with R6 also neighborship will come up, and then finally I have to form IBC peering in between R5 and R6 as well. But this time I will not make this R6 member of peer group. I will define it manually, like neighbor 150.1.6.1, remote AS is 65500, and then update source is what? Loopback 0. Interface loopback 1, and here I'll be using 50 subnetwork 50.1.1, and then finally advertise it into BGP itself. In same manner, move on R6, configure one loopback over here as well. Allocate 60 subnet. 60.1.1, and finally just go to router mode and configure neighborship with R5, and then advertise these 60 prefixes. What? Fine. But I have not configured R5 as a client for R6, as well as I have not configured this R6 as a client for R5. Means for R5, R6 is non-client, for R6, R5 is non-client. Fine. See, now on R1, to reach R2's loopback, it can reach it via, see, by looking at BGP table, it shows that it's coming from R2 itself, right? And how is it possible to receive same prefix from two times from the same neighbor? No, it's not receiving it from the same neighbor, because next hop is not, next hop will never get changed in IBGP. That is why when R2 given this prefix to R5 and R6, R5 and R6, both of them are also giving it back to R1. Hey, R2 have advertised these prefixes towards R5 and R6, and then R5 and R6, both of them are giving it back to R1 without modifying their next hop address. And that is why it is really good for us that next hop address was not changed, so that whenever you will start to go from R1 to R2, you will directly go in the direction of R2. You will never go via R5 or via R6 in this physical diagram. Is not it? Whenever you will require to ping, or whenever you will require to transmit your data from R1 to R2, it will directly go in the direction of R2. And you see that from R1, which one is best? This one is best. And now by looking at BGP table, you cannot decide that whether via R5 it is best or via R6. To know that, actually you have to open it in more details, like 20.1.0. check it out. Lower neighbor router ID, this is best, but doesn't matter which one is best, because it has to go through directly. It has to go directly towards R2, because next hop is common via both neighbors, right? But the problem is this time, see, if you move on R6, if you check BGP table of R6, this is the problem now. Like 10's prefix is coming from R1, but also it is given from R5 as well. Let me show you on R6. Show IP BGP 10.1.0. It's coming from R1. That's good. That's very good that it is coming from R1. But why it is coming from R5? See, it means that this time in a single cluster you are having same cluster IDs on R5, sorry, different cluster IDs on R5 and R6. That is why R6 is receiving prefixes coming from R5. That is why R6 is receiving prefixes coming from R5, and R5 will also receive prefixes coming from R6. It should not happen because all of them are in a single cluster. So do one thing, on R6 and R5 configure common cluster IDs now. So say BGP cluster ID is like 5.5.5 on R5, and on R6 also I'll configure the same one, router BGP 65500. BGP cluster ID is what? Sorry. And now show IP BGP. Check it out. It have stopped to receive anything from R5. But still you will see that it is receiving one prefix from R5, which is 50's prefix. Of course it will come. And remember that if route reflector advertised its self-advertised prefix to its neighbor, it will not add those two attributes. Try to understand. If route reflector is advertising its own prefixes, it will not add those two attributes like originator ID and cluster list. Because for its own prefixes it is not working as a route reflector. It is working route reflector only for those prefixes which have been received from its IBGP neighbor. So when R5 will advertise its own prefix information in the direction of R6, it will not add information. It will not add those two attributes. That is why R6 is still receiving the prefix of R5. See, 50's prefix. So IPBGP 50.1.0. You will not find anything like cluster list or originator ID in it. Do you have that? But if you open so IPBGP, because this time you are receiving it from client. R6 is receiving it from client. So in it you will see that
received from
RR client, and whenever it will advertise it towards any other neighbor, before advertising it towards any other neighbor, it will add those two attributes. Like you do one thing, move on R2 and you open show IP BGP 10.1.0, which is given from both of them. See, when it is given from R5, then in originator ID it is the router ID of R1 because R5 got it from R1 itself. But in cluster list R5 have added its own cluster ID. It is also receiving the same prefix from R6 as well. It is also receiving same prefix from R6 as well. Originator ID is same, but and cluster list is also given from R6. So it has proved that whenever route reflector will receive any prefix from one of the client, will advertise it towards any other client, it will add these two things. But if it is advertising its own prefix, it will not add that. Like on R2 itself, if you open show IP BGP 50.1.0, see, if it is coming from R5, see, if it is coming from R5, this entry is from R5, right? It is not having those two attributes here. But if it is receiving it from R6, because R6 got it from R5 and then further R6 is giving it to R2. So it has added those two attributes now, originator ID and cluster ID. So there will never be any routing loop, never ever. And this is the uses of redundant route reflector, right? So in this way they are performing. So in case if any one of the router goes down, then also there will not be any problem. Like let me do one thing. On R5, what will I do? I'll say neighbor CCIE is what? Because it was my peer group, if you remember. So all of them will go down now. But still they are having neighborship with R6. So still they will be having each other's prefixes available inside their BGP table, you see. Have you understood it or not? So this is the advantage of having redundant route reflector. But remember, in a single cluster means all route reflectors in that cluster must have same cluster ID. Move on R5, say no shutdown. Once again neighborship will come up. So in this way you can configure route reflectors with one redundant route reflector. Let's go for another diagram, and this time I will modify this diagram. This time I will be having two different clusters. This time I will be having two different clusters in this way. Like I'll be having R1 will be having neighborship with R2 with R3 as well, in this way. Then R1 will be further connected with there is no R3, so I'll be taking R4. So it will be further connected with R5, and R5 will be connected with R6. So I'm having one, like I'll define it in a single cluster. and I'll define it in a single cluster. So I'll define this R1 as a route reflector, it will be client, R5 as route reflector, it will be client, but for R5 R1 will be non-client, for R1 R5 will be non-client. This is R5, see. So this time these two route reflectors must have different cluster IDs. If they are having same cluster ID, then of course there will be a big problem.
Routes will not go.
Exactly. Are you getting my point or not? So in this way you can define here route reflectors at advanced level. So let's do one thing once again, remove this BGP from all devices. Fine guys. Let's configure it once again, this R1. Remote AS is what? Update source. Then neighbor is what? Right, and neighbor is and then update source is networks and .1.0. This is R1. R1 is having neighborship with R2, R4 as well as R5. So that's what I configured on R1, right? Then move on R2. On R2 it is having neighborship with R1 only. So router BGP neighbor, neighbor is configured. Now advertise your prefix. Fine. In same manner you have to move on. Router BGP 65500 neighbor. Remote AS is, and then you have to define your which is, and then finally
So these topics will be covered in CCA.
everything. Fine guys. So now let's move on. R5. So we have to configure R5 as well. Say router BGP 65500 is having neighborship with 150.1.1. Remote AS is what? 65500 and update source is loopback 0. Then neighbor 150.1.6.1. Remote AS is what? 65500 and update source will be loopback 0. And then network 50.1.0 and finally move on R6. Router BGP 65500 neighbor 150.1.5.1 remote AS 65500 update source is loopback 0 and network 60.1.0 mask will be. So now this time you will see, because I have not configured any router as a route reflector, so R1 will be having prefixes coming from R2, R4 as well as R5 because they are directly connecting neighbors. They are directly IBGP peers, right? But R1 is not gonna to advertise prefixes coming from R2 and R4 in the direction of R5. And also if R1 is receiving anything from R5, it will not advertise it towards R2 as well as R4. Even R1 won't be able to exchange prefixes in between R2 and R4. Fine. Check it out. Only R5 is prefix. If you move on R5, R5 will be receiving prefixes of R1 as well as R6. If you move on R1, then it will be receiving prefixes from R2, R4 as well as R5. Check it out. Okay, it means R4. On R4 I didn't advertise. Okay, I didn't configure. Router BGP 65500. Neighbor 150.1.1.1. Remote AS is what? 65500. Update source is what? Loopback 0 and network 40.1.0. Mask will be see. Is not it? Now there will be requirement of configuring route reflectors. Of course, without route reflectors, you cannot exchange routes in between them. So do one thing, move back again on R1. Router BGP 65500, neighbor 150.1. What? Tell me, if you want to configure R1 as a route reflector, what will be your command?
R2 or
So neighbor, tell me. What? Then?
4.
Fine. Now you will see that it will start to exchange prefixes in between R2 and R4. So if you move on R2, it must get R4s as well as it have also received R5s, but still it have not received anything from. And you see, so BGP 40.1.0. Originator ID is the router ID of R4. Cluster list is having router ID of, cluster ID of route reflector, which is R1. Even if you open so BGP 50.1.1.0, you can see the same thing. Now on R5 also you will get everything, because R1 can advertise towards non-client everything, right? So on R5 you are having everything, but R5 will not be able to advertise it towards R6 now. It means that on R6 you can get anything without configuring this R5 as a route reflector. So now you do one thing, move back again on R5 and say router BGP 65500 and neighbor 150.1.6.1 is what? Route reflector client. Once you will configure it as a route reflector client, you will see that on R6 all prefixes will be available. Check it out. Even now on R1 or on R2 actually, on R2 you can also get R6 prefix as well. See, and if you open it now, so IP BGP 60.1.0. Check it out. See, cluster list is having now, whereas originator ID is still same. It's not it. So in this way, route reflector works. Originator ID is same as previously. Like of course, this prefix was received on route reflector R5 from R6. So R5 put its originator ID as the router ID of R6 because R5 received them from R6 itself. And then you see cluster list. It has been prepended by, cluster IDs have been prepended by route reflector. So first of all, it was prepended by R5 because R5 was the first route reflector, and then got it. In same manner, you can move on R6. You can also open prefix coming from R2, originator ID, cluster list. Now if you configure their cluster ID is same onto R1 and R5, then they will not be able to exchange prefixes with each other except their own, right? So you do one thing, move on R1 now. Router BGP 65500, BGP cluster ID, BGP cluster ID, and then let's say, and same I'll configure on now. R5 will not receive any prefix coming from R1, I mean refracted by R1. See, 20s and 40s prefix is not there. Understood? Any problem now? So in T-shoot, they can do this. They will be having two different clusters, and on both route reflectors they will configure same cluster IDs, and you will see that they will not be able to exchange their prefixes with each other. So you have to be very careful. So on R5, once again I'll move there and I'll configure BGP cluster ID as 5.5.5. And once again you will see that. See, everything is there. So in this way you can configure route reflectors at large scale. I mean, now you have understood everything that happens in the behind of route reflectors actually. So basically route reflectors are playing with the help of originator ID and cluster list only. And whenever these updates will go out from, like if I configure neighborship in between R6 and BT, then you will see, let me configure it, that these attributes will be stripped from outgoing updates. So router BGP 65500, neighbor is 201.100.100.1, remote AS is 35500. So it will form neighborship with BT, and also it will advertise those prefixes in the direction of BT now. Let me show you. Show IP BGP summary. Have came up now. It have received all those prefixes. So IP BCP 10 dot, or you can say 20.1.0. Does it have any information like originator ID or cluster list? Fine. Understood? So in this way you will configure route reflectors. Now let's go for confederation. So once again let me remove BGP from all these 6 routers. I mean 5 routers actually. Fine guys. Okay, so this time I'll be drawing this diagram in this way actually, like there is R5, R1, R2, R4, R6. And then R5 and R6 are having neighborship with BT. Fine. So these 5 routers are participating in this main AS 65500. But what will I do? I will create some sub ASs. On R5 I will use AS 655, or you say AS5 only. On R1 I'll use AS1. On R2 I'll use AS2. On R4 I'll use AS4. On R6 I'll use AS6. So this time I will not use route reflectors. Along with
Sub AS.
confederation.
Conflict.
This time I'll be configuring only and only confederation. However, it is always you will always find in production networks that you will be using confederation along with route reflectors. So basically you will be using confederation just to reduce total number of route reflectors in your network, right? So but this time see, all of them will be EBGP, confed EBGP neighbors, right?
Yes.
So I'll show you that most of the features are from IBGP neighbors, but some of the features are also
BGP.
from real EBGP, in confed EBGP, right? So let's do it now. On R5, I'll start from R5. Router BGP, I wanted to configure 5. Now you have to tell this router that this is your main AS, primary AS,
Okay.
like BGP configuration identifier. With using this command, you will tell your router, your BGP, that this is your main AS, primary AS, which was 655.0. Now, say neighbor 200.105.100.1 remote AS is what? 355, which is EBGP DT. You will see neighborship will come up. See? However, you have configured AS 5.
Yes, but
Did you configure remote AS 5 on BT? On BT still you are running remote AS as 655.0. I have not modified any configuration, any initial configuration of BT.
okay.
Then say neighbor 150.1.1.1. One more thing. If you are having your confed EBGP neighbor, and if it is confed EBGP neighbor, it means it will be in different sub AS.
Okay.
So if you are having your neighbor in different sub AS, then you have to configure this command as well. BGP confederation peer, and then you have to tell those sub ASs in which your peers are existing. So this time I'm having only one sub AS in which I'm having my peer, which is only 1. And then define neighbor 150.1.1 remote AS is what? 1. You have to tell about your sub AS only.
Yeah.
And then neighbor 150.1.1 update source is what? Loopback. But it still do show IP BGP summary. Let me show you that it will remain in ideal state because TTL, due to TTL, because it is also having some features of real EBGP. So you have to change your TTL value as well. So say neighbor 150.1.1.1 EBGP multi-hop is like 2 or 3, whatever it is, right? Now do show IP BGP summary. You will see that your neighborship will move from ideal to active. Now move on R1. Router BGP is what? BGP confederation identifier is what? 655. Then BGP confederation peers. This time R1 is having peers in two different ASs. One is 5, which is R5. One is 2, which is R2. And then after say neighbor 150.1.5.1 remote AS is what? 5. The neighbor 150.1.5.1 update source is loopback 0. The neighbor 150.1.5.1 EBGP multi-hop is what? And then neighbor network 10.1.0 mask is what? Are you getting my point or not? Move back again on R5 as well. Even on R5 also you can advertise 50s network. Understood? Then you do one thing, move on R2 now. And on R2, say router BGP is what?
2.
BGP confederation identifier,
655.
which is main AS. Then BGP confederation peers. You have to specify those sub ASs in which you are having peers. 1 and 4. Neighbor 150.1.1.1 remote AS is what? 1. Neighbor 150.1.1 update source is loopback 0. neighbor 150.1.1 EBGP multi-hop is to neighbor network. Okay, you are also having one another neighbor 150.1.4.1. remote AS is for neighbor 150.1.4.1. update source is loopback 0. neighbor 150.1.4.1 EBGP multi-hop is what? network 20.1.0. mask value will be then you can also move on. Router first of all BGP confederation identifier 65500, then BGP confederation
Here. 1 and 6. 2 and 6.
you understand? And before going to configure this R4, let's move on R1. Let me show you BGP table of R1. So I be BGP. See, these prefixes, 50 prefixes coming with local preference. However, it is EBGP enable, but this time it took this feature from IBGP. And also next hop have not been changed, and that is why these are not best via from R1. See, because R5 is advertising them towards R1 without modifying next hop. So this feature was also taken from IBGP. So you have to move on R5 and neighbor 150.1.1 say next hop. Now you move back again on R1. It's best now. And now it will also advertise. See, for R1, R2 is EBGP, confed EBGP. Let me show you. Show IP BGP neighbor 150.1.2.1 on R2.
R1 पे R2 के साथ neighbor
router BGP 1 neighbor 150.1.2.1 remote AS is what? 2 neighbor 150.1.2.1 update source is loopback 0 neighbor 150.1.2.1 EBGP multi-hop is what? Wait. Yes. See, again next hop has not been changed, but this time it is reachable. There will not be any problem because it is in a same AS, right? And let me show you. See, these prefixes are coming after crossing two sub-ASs. Sub-ASs will always be mentioned in brackets. Sub-ASs will always be mentioned in brackets. See? So R2 will defined. We'll make them as best very soon. See? It's best because this time next hop addresses are reachable. But if you open show IP BGP like neighbor 150.1.1, so it will show you. What is it showing you? But thing is show IP BGP 192.168.100.0 confed external, right? So this is confed external for R2 because it is receiving it from confed EBGP neighbor R1. Hello, this is confed EBGP neighbor, right guys? So in this way you can configure confederation, fine. And then after, and remember that these sub ASs will never participate in your best path selection in BGP.
No.
These sub ASs will never participate in your BGP best path selection, fine. Now you do one thing, move back again on R4. BGP confederation peers are in 2 and 6. The neighbor 150.1.2.1 remote AS is 2. Then update source is loopback 0. EBGP multi-hop 2 or 3 would be enough. The neighbor 150.1.6.1. Move on. Router BGP. In 4 only. Is not it? And then? And then neighbor. Fine. You have to configure next hop self as well over here. Otherwise, it will receive prefixes from EBGP neighbor, will advertise towards confed EBGP neighbor without modifying next hop. It have received it from there. It will advertise. See, it is also receiving it from 5. Next hop is 5 because next hop will never get changed. However, it is receiving this prefix from R4 because for R4 its best path will be definitely via R5 because via R6 it's not reachable. Next hop address is not reachable. Even you can go there on R4, you can check it out. See, 192's prefixes. Next hop is not changed. So do one thing, move back again on R6 and configure 150.1.4.1. Next hop is what? Self. Once you will configure this command, now move back again on R4. Show IP BGP. Now its best path is via, still it is via R5. You know why? You can check it out. Show IP BGP 192.168.100.0. First of all, is metric from R4. It's just 2. Is not it? So basically these sub ASs are not participating. Otherwise via R5 it has to across 3 sub ASs, whereas via R6 it has to across only 1 sub AS. So remember that sub ASs will never participate in your best path selection. But IGP cost, see, to reach next hop. Understood? Hello?
Yes.
So this time you are not required to configure route reflectors, and you can see that all of them have exchanged prefixes with each other. You can see that on R4 you are having all prefixes. See, 10, 20, 40, 50. You can also have 60 because 60 I think I didn't advertise it on R6. That is why you are not receiving here 60. But you can see that 50 prefix is there. So here you will not require to configure route reflectors, and in this manner your configuration will work. So as you have seen that some of the features, I mean for confed EBGP, some of the features were taken from IBGP and some of the features were taken from real EBGP. But remember that for confed EBGP, you will see that local preference will always be part of your BGP updates. Is not it? Like see, they are coming from EBGP, but local preference is still there because they are confed EBGP, they are not real EBGP. So whenever BGP will give any update to its confed EBGP, then definitely it will add information. I mean, it will carry local preference in its BGP updates. Understood or not?
Yes.
So this is all about the configuration. I mean, in this way you can configure your configuration. But remember, along with configuration also you can configure, because you can put multiple routers in a single sub AS as well. So if you are having multiple routers in a single sub AS, then you will require to configure route reflectors. So I don't think so that it is necessary for me to perform that practical as well. You people can do it now by yourself. And remember, inside configuration that you configure this command, peer command, will be configured in that case only when you are having neighbors, your confed EBGP, I mean your neighbors in different sub AS. If your neighbors are in same sub AS, then you will not require to configure this peer command. Understood? And see, whenever updates will go out from its own AS, these sub ASs will be stripped from outgoing updates whenever it will give those updates to its really BGP neighbor. So let's move on BT now. Check it out. These 10s, 20s prefixes are coming from there, right? So IP BGP 10.1.0. Check it out.
Right.
Nothing, no information about the sub ASs, right? So this is same as like private VLANs.
Private.
Have you understood it or not?
Yes.
So that's all about router factors and confederation. So tomorrow I will complete your communities, and then after communities, maximum 1 or 2 classes will be required for BGP. I mean, most of the part of BGP will be covered in tomorrow's class. Then after we will be having some small practicals, but really important in BGP. Right?